All right, what I want to do in this video is get the engine compiling on Linux. So I'm on Windows right now. I have WSL2 installed, and if I look at my version, I am on the latest version of 22.04, and through WSL2 I can go to like my C drive, and inside of my C drive I can see the AftrBurner engine. So I have the engine and I have userland. And just like on Windows, what we expect to do is compile the engine, install the engine, and then run a module. This will probably be a longer video because I'm going to work through it step by step, even though there are sort of like hints and updates and documents that show how this is done. But this way you'll be able to see, oh, when you encounter this error or that error, maybe I'll be able to resolve it. So the first thing I'm going to start to do is try to install the engine. And by install the engine, I mean compile the engine. Now, I already have it compiling and working fine on Windows. So that's that Win64 folder where CMake produces my Visual Studio solution. The engine compiles and runs properly here. So what I'm going to do is I'll go into the engine folder and I'm going to make a build release folder for Linux. Okay, so I'll go into my build release folder, and the first thing that I would normally do is I would say, hey, let's run CMake, the console-based CMake, and let's point it at source after. Why source after? Because source after, this is where the CMake list.txt is. Now, I'm pretty sure I haven't installed, I haven't installed anything yet on this version of Ubuntu. So, how do we get started? Well, in the engine folder, one of the files in here is the Linux apt install packages for AftrBurner. If we open up this little guy, and we'll bring them over here. Oops, where are we going? There we go. This has the steps that we need to go through to install. This is very close to how you could also set up your own Docker environment if you want to use Docker. And as a matter of fact, in Engine, there is a Docker folder. Now this Docker dev, this dev file, if you open this up, it has very similar instructions as this Linux apt apt install packages for AftrBurner, except this Linux apt apt install packages as of April 8th, 2024 is more up to date. So the Docker should still work, but some of the libraries in it are really old. So for example, SDL, we're using 2.28. This Docker might point to an older version of SDL. So if I look in here, it's at 2.0 instead of 2.28. So it's pretty old, but if you updated the versions, everything should still work. So anyway, the first thing I need to do is I need to get GCC 13.1. You need to have at least 13.1 to compile the engine. Otherwise, certain aspects of modern C++ that I use in the engine won't compile. So we will install the software properties. Looks like that was already installed. I will install the repository for GCC 13.1, or at least add it to my repo. And now when I, update, all right, anyway, now let me do my update, sudo apt update. It should pull in that. And now I should be able to install GCC 13 and G++ 13. The -y at the end here says, don't prompt for are you sure? So we'll hit that. Oh, it says it's all installed now. G++ is not followed, but can be installed. Okay, I need to then update the alternatives to use GCC 13. So now, if I check out G++, I now have G++ 13.1 installed. I guess an easy way to now install CMake should be, let's install CMake. I'm not quite sure what that classic does. We'll see what that does. Let's snap install it. I don't know. And then if we run ccmake, let's see if it what version it gives me. Version 3.29. That is new enough to do all of the things that we want to do. So we have a good version of CMake, and I like Ninja a little bit better than just Make. So we'll install Ninja. Ninja seems to be a little faster. One of the things we're going to need also is Boost. Now, on the C drive, inside of the libs folder, I already have Boost on Windows. However, if I sort of stick this here, if we look, this Boost is the MSVC installer, right? So this already has the precompiled binaries for Windows, which isn't great because I need to compile the source for Linux, and I am uncertain if all the build tools come with that Windows installer. So the easiest way is to just get this newer version, or this version of source code for Boost. So right here, I will get, I'll go into this libs folder, and I'll execute wget, and I'll get the Boost 183 bzip2. This should download pretty quickly. Then what we're going to want to do is gunzip-d to decompress Boost. So we'll, actually, I'll show you right here. So we have Boost tar.bzip2, and to extract a bzip2, you can say gunzip-d, the gz. Wait, this says bzip2. Did I get a bzip2? Oh, okay. So this should be bunzip, maybe? All right, maybe gunzip will undo it too. But this is a tar dot, it's not a gz. It is a, it says bzip2. Yeah, it doesn't seem to like that. So, does gunzip do gunzip -d boost? Nope. All right, bzip. I think there's a bzip -d. Is there a bzip? Bzip was not found. Okay. So, like all good things, we will basically say Linux unzip bz2. Is it bz2 utility? bzip2. Yeah, that's what I thought. bzip2. Do I not have that? Bzip. Oh, bzip2. Is that what I need? Sudo apt install bzip2. All right. Now, let's see here. bzip2, I'm guessing to decompress Boost 183 bzip. Let's see what happens. Hopefully that does something useful. We can sanity check on Windows. Yeah, we're getting a Boost tar file right here, which is exactly what we expect. So we use bzip2, and then afterwards we can say, let's run tar xf to extract the files inside of that tar file, and that will create the folder Boost 183. Once Boost 183 is created, we will run the bootstrap and the installer. So right now we're just waiting on the file system to extract, and once that completes, we should be good to go. All right, and if we sort of look at what's going on here, we're at, there we go, 700 megs. So let's extract. We'll extract the tar file. This will create the folder. So now we should see Boost 183. Boost 183 is getting extracted. That's lots of fun. Then after that, we will be able to go into Boost and run the bootstrap and then compile it and install it. The reason this is a little slow is because there are many files, like thousands of files that will appear inside of this folder. And it's a little bit slower doing NTFS intensive file operations. in WSL2 versus on like a native ext3 or ext4 file system. Anyway, this will finish. It'll still be pretty fast. And then we will be able to do our bootstrap when we change our directory into it and run this. And then these commands right here are just installing the image libraries like JPEG, PNG, and that kind of stuff. Then we will install Glue, which is the GL extension wrangler. This lets us query our graphics card to get the function pointer to the OpenGL functions provided by, in this case, my NVIDIA RTX 4090. Through whatever interface WSL2 uses with Windows. Yeah, so hopefully this will finish up pretty soon. Actually, I'll be bad. While that's doing that, I'll just start working on some of the other libraries. So Boost is still doing stuff. While Boost does that, I'm going to get these libjpeg and all of these guys. We'll just sort of paste those in there. Install all of these. Then we'll do the same for libglue dev. All right. Now, for SDL2, this guy right here is saying, hey, let's wget SDL2. That's all of this stuff. We already have SDL2 2.28, and that is right here. However, this is an install. So I built this for Windows and stuck it here. So not the entire set of source code is actually in here. So what I will actually do is make, I don't know, I'll just make a new folder here called Linux, and I'll go into Linux, and then I will run this command that will wget our source code for this. It downloads the source code. Then we will gunzip it, tar it, extract the tar, and go into the directory. So it will unzip it, tar it, go into SDL2. There we go. Now we're in that folder. We should be. Yeah, we're in Linux. Then what we should be able to do right here is just use ccmake, and we will build using the default options. So I'll make a, I don't know, a build folder, and out of source build folder. We'll go into build, and I'll say, hey, let's run cmake. And cmake is right here in the root of the directory. So all I need to say is, hey, let's run cmake. We will do the configure. Unable to find Unix make files. Configure? Quit. Let me see here. Okay, ccmake generate ninja // configure. Okay, wants me to do this, so let's arm-rf star. Now I'm going to use the ninja generator because I may not have installed auto tools, so we'll use ninja. That's cool. And that's what I did with ccmake. I said ccmake -G generate a ninja project. Ninja and makefiles are the same thing. Functionally, they do the same thing. Ninja is a little newer. It runs faster, all that kind of stuff. So I'll use ninja. And then after I make ninja, instead of saying make J16, I will have to say ninja. I'll just type ninja and it will run ninja. And then after that, I can say, instead of make install, I'll say ninja install, sudo ninja install. And then it will install the Linux version of SDL 2.28 into my Linux file system. So while that's doing all that, my Boost version should be done. Okay, so Boost is now done. It's extracted. It's right here. I'm going to run the bootstrap.sh. So I probably need to chmod + x onto my bootstrap. Oh, it's already there. So I don't need to do that. It's already done. So we'll say let's bootstrap, and it looks like it is starting to do things. So it's starting to compile. This will take a minute. Oh, here we go. So bootstrapping is done. To build, run B2. All right, so let's run B2. And I'm pretty sure by default it is multi-threaded. I'm just going to do the default option. Boost has its own little build system. Yeah, I'm just going to run B2. So we'll just say, hey, let's run B2 like the instructions told me. I'm sure it will use plenty of my CPUs. So if I look at my CPUs, once it starts compiling, I would expect that it'll jump up a little bit, maybe. Anyway, that's starting to run. Let's go back to SDL. Where were we with SDL? We found, or we were running CMake on SDL, and we're using the default options, so we can configure that. One of the other things that we notice here, though, is it does find things like libjpeg and libpng because I've already installed those. So I think like if I hit T and toggle on complicated or advanced mode, we'll see that somewhere in here it says, hey, I found libjpeg, I found this, that, and the other thing. And all these default options, which are like preprocessor directives, should be completely okay. So we'll just say, hey, let's go on with that configure. And that should be, looks like everything should be okay. And we can exit this and we'll hit G to generate. So now we have generated our Ninja file. If I look down, we're going to see in this build folder that I now have build.ninja. So I can say, hey, let's ninja this guy up. And when we do this, this is starting to compile, and it's utilizing a decent number of CPU cores. While that's going on, Boost is still compiling and doing its thing. So we're compiling SDL, and we are compiling Boost. We have 128 CPUs, so shouldn't take too long. We have now compiled SDL, so I can say sudo ninja install, and this should copy the header files and static and dynamic libraries into my Ubuntu file system, into like user include, user bin, user lib, all that kind of stuff. So hopefully I get feedback that that completes successfully. And here it is copying stuff. And again, it's a little slow right now because Boost is still busy compiling behind the scenes. As a matter of fact, it looks like Boost is using up a decent amount of CPU stuff right now because it's compiling all of Boost. So, all right, we have SDL2 done. But, of course, we also need SDL2 image. SDL2 image. So, to do that, I will wget SDL2 image. All right, and I'll just put it inside of that same Linux folder. And again, this is just where I'm building stuff. So once I've built it and installed it on my Linux system, I could delete these files. It's not that important. So we'll go SDL2 Linux. Where are we? Oh yeah, let's gunzip -d our SDL2 image, and then after we gunzip it, we can see we have the tarball. So let's extract the files from the SDL2 image tarball. We will then have that. Boost is still cranking away over here. So, oh, Boost just finished. Excellent. All right, so once Boost is done, do I need to do like I need to run, like the instructions say right here, B2 install. So I'll say B2 install. I really wonder if I need a sudo in front of that, because if I'm writing to my file system, I probably need a sudo. So I'll just say sudo B2 install. Let that start to copy around. Then we have extracted the tarball, and we now have our SDL2 image. So in this, again, let's make our build folder. We'll go into build. And again, I want to run CMake using the default options. So I will say Again, right in this folder, I expect to see a CMake. Here's my CMake list.txt. That's how I know where I point CMake at. We'll say CMake, please make a Ninja generator and point it up one folder from build to the root. It should find that. When I do this configure, it should already find SDL2. And so you can see down here, hey, I found SDL2 and I found SDL library. This is the folder where that SDL2 install, when I said sudo ninja install, that's where it copied these files to. So we can do a configure on this, we'll generate, and now we can say ninja. So this is going to compile away. It has now already compiled. And now we can say sudo ninja install. So we hit that, it's installed, boom, we're done, everybody's happy. Boost is still doing its sudo boost install. It's still doing its thing. Boost is the biggest library. Oh, there it is. Copying. This is it where it's copying. If you forgot sudo, this copy command would give you write permission errors and it would not install boost. Okay, so good. We're all updated now. Boost should be complete. We're done with SDL2 image, and now we need libasmp. Libasmp is an asset importer. This is what we use to like read OBJ files, 3ds files, PLY files, all kinds of different files. So let's start on this, and because I'm already on Windows, I have ASMP already. And on Windows, we're using this ASMP 5.01. However, with Linux, we can get this 5.25. This works fine. So we'll just get the version 5.25. We'll download that. I will gunzip it to extract that version 5.25. I will then extract it, and I'll go into the ASM 525 folder that it creates. So I will run this, run these commands. And then this will extract, unzip, extract, and then it'll take me into that folder. Once I'm into that folder, which is where I'm in right here, I need to run CMake again, right? We use CMake so we can get the Ninja file. Then from Ninja, we can install it. This one is a little different. That being said, I still have my CMake lists right here, so I can make my build. Let me make a dir for build. All right, and now I'm going to run CMake. Let's make a beautiful Ninja file, and I'm going to go back one folder. But the instructions right here say ensure in CMake you set ASMP no export equals on. All right, so let's run that. Let's see what that means. We're going to hit configure. This is where it's going to scan my system, figure out all the dependencies it may or may not need. And then in here it says, hey, set the preprocessor directive to ASMP export equals on. And I am not quite sure what this does. It says disable ASMP's export functionality. Looks like we don't want to do that because I've done this before and for some reason I needed to turn it on to make it work. So I turn that on. I can hit configure and generate. Now I should be able to, right here, I have my build.ninja, so I can say, let's ninja this guy up. We'll start to ninja. Everything should compile. My CPUs are up to using 64 cores. We're zipping through here pretty quickly. And then after that, I'm going to say sudo ninja install. And then after that, ASMP will be done. And we're well on our way to making good progress. All right, and so hopefully you're kind of getting the hang of this. It's like you download a library, you extract the library, you compile the library by using CMake to make a Ninja file, and then you run Ninja. The only thing you have to make sure is you set the flags the way the flags ought to be made, according to this documentation. And then after all of the stuff compiles, you also have to say sudo ninja install. All right. So we're on a linking stage right here. Oh, yep, linking. Linking is where it takes all of the .o files, concatenates all of them together into the library. And now I should be able to say sudo ninja install. So sudo ninja install, boom, now we have asimp. Again, if I forgot sudo, I would get permission errors with that, and that would be bad. All right, we're in libs. We're back in libs. The other dependency that I'll need is libfmt. That's a wonderful library. I already have libfmt on Windows, but again, I compiled it for Windows, and this doesn't have all of the source code for the whole repository. It's just like the minimum, here's my headers and precompiled libs for Windows. So I'll make, I don't know, I'll go into the format folder, and I'll make a Linux folder. And then in Linux, I will download the tar file, and we'll go in here, gunzip it, tar it. After it's tarred, we'll go into it. So I'll go into the lib format, and then we have another CMake list, so I'll make my build dir. In build, I will run ccmake, generate the ninja file, and run that. We'll hit configure. This is where it'll find, you know, my processor again. I don't need the doc. Turn off docs and tests, we don't need it. So I'll turn off the doc, and I say turn off docs and tests, we don't need it because it says right here, turn off doc and test, we don't need it. All right, so we'll turn those, we'll hit configure, and remember, every time I change an option here, I have to repress C. I'm pushing the C key. C says configure. And then after it configures, and I hit configure a sufficient number of times, this magical G key will appear. G means generate, and this is where it writes ninja.build or build.ninja to the hard drive. So now build.ninja exists, and let's ninja it up. All right, so this will compile libfmt, then sudo ninja install. It'll call that, boom, lib format's done. For some of the math, we need eigen. Eigen is also a nice, great linear algebra library. And again, inside of eigen, this is effectively, you know, my Windows install. So I need to get the Linux source code and build it on Linux, install it on my Linux system, just like everything else. So to do that, let's make our dir for Linux. There's our Linux folder. And let's go ahead and wget these versions. I believe these versions are still relatively recent. I mean, they shouldn't be ancient. So we will gunzip this, extract it, and change into that directory. Okay, tar xf eigen. Oh, so there's a typo in this. I'm going to fix that typo in this file. All right, there we go. Tar extract that. And once this guy is extracted, I will go in. Here's eigen. Now I can make my build folder because I see CMake list right here. So I'll go into build, and I will run ccmake. Let's generate a ninja file, up one folder, and are there any rules? Turn off testing, doc, and mathjax. All right, so we'll hit configure. Testing, you know, we're just installing it on our system. If you were a developer for eigen, you would want to install the test so you can run the unit test. For AftrBurner, you run the tests in the engine to give the unit tests, okay? The other setup, doc, that's just, I don't know, documentation stuff. And then mathjax is how you can render like LaTeX type equations through like a web interface like HTML. So it lets you have really pretty equations in your documentation, which is important for a linear algebra library. So it says right here, don't forget to run the install, right? So we'll run the install. It says CMake, build, target. Yeah, we could actually be using CMake for all these. CMake -- build instead of calling Ninja. That's actually a good idea. Anyway, I'm going to hit configure. make sure that everything is, I need to hit configure until I can hit generate. So configure is a little slow sometimes for these larger libraries. All right, now let's turn off the dock. Let's turn off the test. This is just eigen. There, we'll turn off that. Build testing, there it is up there. So we turned off testing, we turned off MathDax, we turned off dock. I have to hit configure again. And then eventually, I now have a generate option G. So I will hit generate. I have my build, so I can say Ninja. Ninja, no work to do. Okay, sudo Ninja install. And then eigen, apparently, is header only. So this is now installing all the headers into my system so I can include it. And I did not need to actually build any headers. There's probably some option where I need a library, like especially if I enable CUDA or something. So anyway, next thing we need, now that we've gotten a decent number of versions of libraries from source code and built from source, some of these also we can just sort of get from apt. So I can install libglm, which is a GL matrix library that sort of reproduces some of the base function calls from OpenGL 2.1, like glue perspective, glue type functions like that. For the most part, AftrBurner re-implements all of those themselves, but I do use GLM to like in unit tests to verify that the after vector does the same thing as the GLM vector. So that's kind of why that's still there. All right, we have this all installed. We have done everything we were supposed to do. So now I can go back to AftrBurner engine. I can go into BR. BR is where I put my build release. BG is where I put my build debug. It's just shorter to type than build or build release or debug. BR, BG, sure, whatever. Now, because all my dependencies are installed, I should be able to run cmake on the engine and actually compile it. So if I say ccmake generate a Ninja file, I have to point it to where the source, the cmake list is, and that is up one directory, source after. Okay, this is a little non-standard, but it's what it is. So we'll hit configure. This should hopefully detect. It's finding all the libraries we installed, like SDL, OpenGL, ASIMP, Glue, a whole bunch of other things. Now, on Linux, we do not need, there are certain things we can turn off, like we can turn off GDAL. Another thing we can turn off is, if we don't have it already, we can turn off Google Test. So we can turn off GDAL. I don't know if I need free type, so I'm going to turn off both free types. I know I don't need them, but I haven't installed them. If you would have apt installed like free type, you can keep those on and everything will be fine. But by default, these instructions don't install it. So turn off free type GL font, and turn off GDAL. Then everything else should be pretty good. And it's a good sanity check to see that, hey, we found boost, we found eigen, we found SDL, we found ASIMP, we found lib format. And if I hit T to go to advanced mode, it shows here's all the compiler flags and everything that are set. It shows here's where some of the other libraries are and all this kind of stuff. So anyway, we'll just hit configure. This should configure successfully, and then when this completes, I should be able to say generate. Now I have the generate, so I'm going to hit G. It should generate. This should work okay. Now I should be able to say Ninja, and this will take the engine, and it will compile it. One of the reasons I wanted to set up and make this video is because I like using GCC and Clang as compilers to give me additional sanitizers like ASAN and TSAN to sanitize and give me additional warnings that MSVC doesn't necessarily always give warnings for. Some of these warnings are intentional, like where I have deprecated set on certain things like get theta and get phi on my spherical vectors. I don't like those anymore. I just say, get relative y rotation, get relative z rotation, that kind of stuff. It makes more sense than calling things theta and phi, because theta and phi, who knows what that means. So right here it compiled, and it linked at the very bottom. It says lib afterburner engine.a. So now that's excellent news. I can say let's ninja install. I don't need sudo here because this doesn't install it to my Linux system. It will install to AftrBurner user, and it's going to put it right here for in my lib64. It's going to put lib afterburner.a, and it's going to appear right here in this folder. And then it's going to also copy all of the header files into this include folder right here, where all those header files will appear here. All right, so let's go back. We can watch it install. I will say ninja install. It will copy the header files, and here is the lib afterburner engine.a. Right, and now all of these header files that are getting copied have the, we'll say, the config and preprocessor directives that say, hey, I'm running on Linux now, right? So you have to be a little careful if you're on the same hard drive running Windows and Linux in the same source folder, like repos AftrBurner. When you install for Linux, you need to go run a Linux module. If you install for Linux and then you try to compile a Windows module without doing an install from MSVC, your header files could be thinking you're still trying to do Linux stuff and get confused. So just keep that straight. Now we have finished compiling the engine. Let's compile and run a new module. So I can go into user hub, and inside of hub there should be a NewModule.zip, which we see right here. Hub, and let me delete that. There's a NewModule.zip. So to unzip that, we can say unzip-d. Maybe I don't need a D, I don't know. NewModule.zip. Unzip doesn't know about, so sudo apt install unzip. All right. Then we can say unzip new module. It didn't like the -d, so we'll just say unzip the new module. Here we go. Now I can go into new module, and now just like the engine and just like every other library, we need to run cmake yet again. So right here, I will make a folder called br because I'm going to build my release. Now, if I had built the engine in debug mode, which I can do using the BG, I would ninja install the engine in debug mode, and then right here I would be running, making my BG dir, right? So just keep it in straight, where when you do that ninja install on the engine, it will either put lib afterburner engine.a, or it will put lib afterburner engine g.a with the underscore debug. It'll have debug stuff in here. So like on Windows, you get the underscore debug.lib or the underscore rel for release.lib. Same in Linux. You would get the afterburner engine.a, that's release, or the afterburner engine either D. I think it would actually be afterburner engine D.a. All right, so anyway, we're in new module. I'm going to make a folder called BR, and in this folder called BR, I have to run cmake, but cmake list is in the source folder. So all I do right here is I say ccmake, generate a beautiful ninja file, go into source. So remember, in the engine, I had to go /source/after. Here, I'm going to say /source because that points me to the cmake list.txt. All right, cool. We will hit configure. This should work correctly for a new module. If you're doing fancy stuff like you're integrating with a Vimba camera or you're using OpenCV or other stuff, then you have to install OpenCV and do all that. This is just sort of the hello world to get a new module running. All right. The easiest way to get OpenCV is probably just to clone the version 4.8 and then also get the contrib folder. And then, because normally when you're using OpenCV, you're also going to need to use the contributions that AftrBurner require for like certain things. In the new module, by default, I have not installed gtest. If I would have installed gtest, I can leave this on. I'm going to turn off gtest right now, and then I will hit configure again. After hitting configure again, I now have the magical G. So down here I can see, hey, look, I can hit G. So let's hit G. And now I can hit Ninja. So before I hit Ninja, there's no executable in this folder, right? But when I hit Ninja, if all goes well and I don't get a linker error, it should link, and then I will have a new module executable. So it's linking right now. This seemingly looks positive. And I now have a new module. In this new module, if we look, it is 15 megs. Because of all the static linking. Okay, so 15 megs, right? 1, 2, 3, 4, 5, 6, yeah. Okay, no big deal. Now, if I try to run new module, if I was on Linux, straight up Linux, not WSL2, this would work. It should pop up right away, and everything should be dandy. Through WSL2, I'm expecting some issue to happen with the compatibility. Yes, so right here, SDL, which is my cross-platform window manager, fails to create an OpenGL context, and it has something to do with... I have not successfully set up X forwarding properly. So there's a couple things I want to try. I vaguely remember encountering this problem one time. And what did I have to do to do that? How to run a module via WSL2.rich text file. So what did I have to do to fix that? On WSL2, I had to install VCXserve, which is always a pretty fun thing to do. So you install VCX server. We export this, and I got this command off the internet somewhere, so it must totally be legit. Let me just add a few things here without... So these instructions were from like when WSL2 first came out. Since that time, I believe, hopefully, things have gotten a little better. Like, for example, if I run xclock, sudo apt install xclock. Oh, it's x11 apps. I'm sorry. We'll get that. Xclock has the ability to open up a window. Right? And if something is set properly, you can do the same thing with the engine. So aftr.conf, if I nano it, one thing I'm going to do is I'm going to turn multi-samples off completely. And then I think this might be one thing. I might need to set like OpenGL, let me try 2.1. Let me try an ancient version of OpenGL 2.1 with no multi-sampling. If I try that and go into BR and run new module, I still get an error. But did I make it a little further? Maybe? Let's see. Yeah, so right here, it says at the top when I first started to run the program, it created a 2.1 OpenGL context, which is junk, right? You have API calls from 1998. And then the vendor right here is the Microsoft Corporation. If your GPU vendor is the Microsoft Corporation, you probably won't get the best performance. If you're on an actual Linux install, you're already up and running. Everything's working fine. So at that point, you would basically be done. This video would be over. I guess we can stick around for a little bit and maybe Google around, but at this point, it's been like over a year since I have tried to run an actual module in Linux. Usually all I have to do with WSL2 is compile it and sort of run the sanitizers and check that kind of stuff out. So I guess let me try doing some of these commands and seeing if any of them make a difference. So let's export libgl always indirect. We'll run it again. I saw a little window pop up for half a second. Oh yeah, did you see that? Yeah, it was right there for a quick second before this thing crashed. And this was crashing something about use free type is not defined, cannot create, blah, blah, blah. Oh, no, that's fine. That's just setting a few things. And this is, everything here should be okay. So this guy is actually throwing an out-of-range exception, which is interesting. It actually makes me want to run GDB and look at the call stack. Because I don't know exactly what line and what source file this is running on. One thing I can do is if I say code source, we'll get VS Code, and I want to see if the module says to the moon or if to the moon is in the engine. I'm trying to figure that out. Fine. To the moon. To the moon. Ah, here we are. Okay, so lib format prints to the moon, and right then it calls load text async, which is under the hood going to be using like a multi-threaded set of things to load an image of the moon. And this shared multimedia set points to images moonmap.jpg. So that images moonmap is shared multimedia images moon map. So it's trying to load this because I have a little model of a moon that's like spinning around. It's trying to load that and draw it. Okay. I wonder if it's actually because I need a shader and OpenGL 2.1 doesn't support that shader. So let me actually, instead of using 2.1, bump up to like 3.2. So I'll save that and we'll run new module again. Ah, something happened. Okay, yeah. So it's been so long since I've used only version 2.1 that I have a little thing somewhere I need to check. And that little thing somewhere is trying to like load a shader that OpenGL 2.1 does not support. For anything you do with me, and you're running on Linux already, that won't be a problem. You can set OpenGL to some other version. One other issue that's a little funky, the mouse sensitivity inside of the module is a little sensitive. So, yeah, there we go. I have to like have my super slow key going on the mouse. And you have a little slider here. I can change the orbit time, and I can bring the radius in a little closer. If I back up, yeah, I have a little airplane right here, and this guy's doing all of the fun things. All right, so we got the module working on WSL2. The only thing I actually maybe needed to do was call export libgl always indirect equals 0, and the rest of the stuff seems to work. I have to keep anti-aliasing turned off, and I want to see if we can go up to version 4.2. So let's go back to this aftr.conf, and instead of 3.2, oops, let's go to see if we can get 4.3. If we can get 4.3, I'll be happy. That'll be super cool. So let's go back to BR. And this 4.3 is a function of if WSL2 and the intermediate like graphics card layer lets me create an OpenGL 4.3 context. Like a year ago, I read a Phoronix article on the internet that said it went up from 4.2 to 4.3, but I haven't tested it yet. Looks like it failed and it could not create a window, which is sad. So if that failed, it's not going to work right. Let's try 4.2. And hopefully this works. All right. Good. Looks like we have some stuff working here. All right, so I'll back up a little bit. And we can see we'll drop in the radius a little bit. We can decrease the orbit time. And all of these things are working. If I turn on my IMGUI demo, I have all kinds of things I can do. Oops. Yeah. The WSL2 does not seem to like it when I drag a window outside of the... so like if I take this and I drag it outside of the window, it doesn't seem to like it all that much. Again, this is me just playing with WSL2. I primarily use it only as a sanity checker. If you were on straight up Linux, again, this would be working fine. All this stuff kind of works just fine out of the box. So if I back up here, let's back up. We have this guy. So if I turn on and look at implot, whoa. So let's see what these guys look like. My clicking location is off a little bit, but it is seemingly working all right. Which is good. Let's do a real-time plot. All right, so we can see that. Let's look at a bar group, stacked plots. Yeah, these are all kinds of fun things we can do in here. Yeah, these are fun. So anyway, we have all of that working. That was pretty much the point of this video. So we have everything up and running on Ubuntu 22.04. This is running through WSL2. I would not recommend trying to do your normal everyday development in WSL2. The X forwarding through it is just too clunky and there's too many weird oddities. I'd recommend a real Linux box or a real Windows box. So yeah, that's the current state of this right now. I will upload this video. Thanks.